Welcome to the deep dive. Today, we're looking skyward, but our focus isn't just on telescopes, it's on the intelligence we're sending out there.
Yeah, intelligence is the right word.
We're diving deep into the growing role of artificial intelligence in, pushing the boundaries of space exploration.
That's right. And for this deep dive, we've uh, pulled together quite a range of sources. We're looking at insights from YouTube channels like Space Unfolded, Future Pulse, and Quantumite, to get that broader view.
Okay.
And then to really get into the nitty-gritty, we're also digging into some detailed articles straight from NASA.
Oh, cool. Which ones?
We've got Here's How AI is Changing NASA's Mars Rover Science, and another called You Can Help Train NASA's Rovers to Better Explore Mars.
Ah, the citizen science angle, too. Great. So our mission today basically is to get a real handle on how AI is, moving past the sci-fi stage.
Exactly. Becoming a tool we really can't do without.
Yeah, how it's helping us explore the universe now and what its truly revolutionary potential might be for the future. Okay, let's jump in. Where's AI making the biggest splash right now in space?
Well, a really fundamental area is just how spacecraft get around. Navigation.
Right. Getting from A to B out there.
Precisely. Think about guiding something across millions, even billions of miles. AI is increasingly letting these spacecraft handle that much more autonomously.
So less moment by moment driving from Earth.
Way less. These AI systems can process sensor data right there on the spot. They can see an obstacle, figure out how to avoid it all by themselves.
Without waiting for instructions.
Exactly. And it's critical for deep space stuff. The distances are so huge, sending a signal and getting a reply back can take, well, minutes or even hours.
Wow, hours.
Yeah. So real-time human control, just not practical. This autonomy doesn't just help them get there. It changes the kinds of missions we can even think about doing. Well, imagine exploring really tricky terrain. Or maybe trying to catch a fleeting event, something time-sensitive. You can't do that if you're waiting half an hour for instructions.
That makes total sense. You definitely don't want that lag time if you're trying to dodge an asteroid.
Hmm.
Okay, so autonomous navigation, huge game changer. What else? What other big roles is AI taking on?
Another massive one is just dealing with the sheer flood of data.
Ah, yeah, the information overload.
Totally. Telescopes, satellites, rovers,
Yeah.
they're constantly sending back unbelievable amounts of information. The volume is just, well, it's staggering.
We're talking scales that are hard to even wrap your head around, right?
Absolutely. And this is where AI really shines. Its ability to just chew through information, process it, analyze it, it's invaluable.
Faster than humans could ever hope to.
Oh, orders of magnitude faster. We've got AI algorithms looking through telescope images, spotting things like new galaxies or maybe exoplanets that could potentially support life.
Yeah.
Stuff that might have just been lost in the noise otherwise.
Finding the needles in the cosmic haystack.
Pretty much. And satellites orbiting Earth use AI to track, subtle climate shifts or spot natural disasters kicking off. And then you've got the rovers on other planets sending back constant streams of data. AI helps us make sense of it all.
So it's like a super smart filter pointing out the important bits.
Exactly that. Highlighting the nuggets in this overwhelming torrent of information.
Right. Okay. Now, you mentioned the rovers. Let's zoom in on Mars for a bit. Perseverance and Curiosity, they seem like they're really on the front lines of AI out there.
They absolutely are. These aren't like the early probes.
Yeah.
They're much more sophisticated. Both of them use AI quite a bit to operate more independently.
Like with driving.
Yeah. Perseverance, for instance, has this really advanced autonomous navigation system. They call it AutoNav.
AutoNav. Okay.
It lets the rover drive across Mars without needing step-by-step instructions from Earth all the time. It builds its own map of the terrain as it goes, spots hazards like rocks or sand traps, and figures out the safest, quickest way to get where the scientists want it to go.
And Curiosity has something similar.
It does, yeah, though Perseverance's system is, let's say, the next generation, more advanced. But the point is, this onboard smarts means they can cover way more ground.
And spend less time waiting for commands, more time doing actual science.
Precisely. They're not just remote-controlled cars. They're more like, well, thinking, exploring robots.
But it's not just about the driving, is it? It's also about the science they do when they get somewhere interesting.
Exactly right. And this is where it gets really cool with Perseverance. It has this instrument called PIXL.
PIXL.
Yeah, PIXL stands for Planetary Instrument for X-ray Lithochemistry. And its AI plays a really intricate role. It uses something called adaptive sampling software.
Adaptive sampling. Okay, that sounds like it gives PIXL some decision-making power. How's that work?
Basically, yeah. It lets PIXL decide for itself exactly where on a rock to focus its most detailed analysis. It uses this super precise robotic system, a hexapod, like 6 little legs,
A hexapod on the end of the arm.
yeah, to position itself perfectly. Then it does some initial scans of the rock surface. The AI inside PIXL looks at those scans, searching for specific minerals.
Minerals that scientists are particularly interested in.
Exactly. Minerals that might tell us about Mars's past environment, clues about whether it could have supported microbial life once.
So the AI is looking for the scientific hotspots on the rock.
That's a great way to put it. The real leap here isn't just that it can analyze minerals, it's that it can prioritize its own investigation right there on Mars.
Without waiting for scientists back on Earth to tell it what to do next.
Right. This isn't just about getting data faster. It actually changes how the science gets done. The rover becomes more of an active partner in the discovery process.
Like a tiny robotic field geologist making its own calls.
Pretty much. Abigail Allwood, she's the PI for PIXL at JPL. She said, we use PIXL's AI to home in on key science.
Home in on key science.
Yeah. Without that AI, scientists would see something maybe interesting in the first scan. Then they'd have to spend rover time and, command time sending instructions back. Like, okay, look closer at that spot.
Which takes ages because of the communication delay.
Exactly. PIXL can make that call itself right then and there. Saves a ton of time.
That's a huge efficiency boost. And you mentioned this hexapod, the 6 legs. Why is that so important for PIXL?
Okay, so Mars has these wild temperature swings, right?
Yeah.
Day to night.
Right. Big differences.
And those temperature changes actually make Perseverance's big robotic arm expand and contract just a tiny bit.
Just from the metal changing temperature.
Yeah. And when you're trying to analyze things at a microscopic level like PIXL does, even a tiny shift could throw your aim way off.
Oh, I see.
So the hexapod makes these incredibly fine adjustments. We're talking micrometers less than the width of a human hair to keep the instrument perfectly positioned, super close to the rock, but not touching it.
Micrometer adjustments automatically compensating for temperature swings on Mars. That's been mind-blowing.
It really is. That precision is key for getting good X-ray data.
Okay, so it's positioned perfectly, then it fires its X-rays. What happens then?
Right. PIXL scans a little patch, zapping it thousands of times with its X-ray beam, building up this detailed grid of data points. Each zap tells it about the elements in the minerals right there.
Okay.
Then the onboard AI crunches that data immediately. If it spots minerals that are really interesting scientifically, maybe ones known to form in water, for example,
Like a potential biosignature?
or just a sign of past water activity, yeah. If it sees something like that, it can automatically trigger what they call a long dwell.
Meaning it stays focused on that spot.
Exactly. It spends much more time collecting even more detailed data just on that one tiny point of interest. This lets PIXL build up a really detailed mineral map of the rock.
So not just what minerals are there, but where they are in relation to each other.
Precisely. How they're distributed, how they connect. That helps scientists piece together how the rock formed and, its potential for hosting past life.
That quote from Abigail Allwood about homing in on key science without constant human checking really hits home. It shows the power of that onboard decision-making.
It really does. And hey, it's not just Perseverance. Curiosity uses AI too, remember?
Right, you mentioned Curiosity. How does it use AI?
Well, one way is it can autonomously pick which rocks to zap with its laser.
It's ChemCam instrument.
Yeah. The rover looks around, analyzes the shape and color of nearby rocks, and uses AI to decide, okay, that rock looks like it might tell us something interesting chemically. Then zap, it fires the laser to vaporize a tiny spot and analyze the composition.
So it's like having a geologist's eye connected to an AI brain deciding where to point the laser. Very cool. Okay, so rovers are getting smarter on the ground. What about everything orbiting above, the satellites? How's AI changing things up there?
AI is becoming super valuable for just running satellite operations more smoothly. Think about all the satellites we have up there now. Huge constellations.
Thousands of them.
Yeah. They need constant little nudges to stay in the right orbits. Their systems need monitoring to make sure they're healthy. And if something goes wrong, you need to spot it fast.
And AI can help automate that.
A lot of it, yes. AI systems can analyze the telemetry data, basically the health and status updates the satellite sends back,
Okay.
and they can predict potential problems before they become serious, maybe detect a subtle sign that a component is starting to degrade.
So predictive maintenance for satellites.
Exactly. That lets ground control be proactive maybe switch to a backup system or adjust operations to extend the satellite's life. AI can also figure out the most efficient way to make those little orbit adjustments, saving fuel and keeping the satellite perfectly positioned.
So AI is kind of like an intelligent fleet manager for our orbital assets.
That's a good way to think about it.
Yeah,
An
yeah.
intelligent manager, yeah.
Sounds like it saves money and makes things more reliable. What about probes going way out, deep space missions?
Well, the principles are similar, but maybe even more critical out there. For systems maintenance on a probe heading to Jupiter or beyond, human help is incredibly far away.
Right, that time lag again, only much worse.
Much worse. So AI is vital for just constantly monitoring the spacecraft's health over potentially decades-long missions. It watches the sensor data, looking for tiny anomalies, predicting potential failures in critical systems like power or propulsion,
Giving mission control a heads up?
giving them a heads up, yeah, so they have time to react, maybe send commands to work around the issue. Or sometimes the AI might even allow the spacecraft to take some corrective action on its own.
Like a self-healing capability.
Sort of, yeah, like building resilience right into the spacecraft itself.
That's an amazing thought. A probe diagnosing and treating itself millions or billions of miles away. Okay, let's zoom back out. Big picture universe stuff. How is AI helping with basic astronomical discoveries?
Oh, this is a really exciting area. Our telescopes on the ground and in space like Hubble and Webb, they gather just incredible amounts of data. So much data.
More than astronomers can possibly look through image by image.
Exactly. It's just too much. AI algorithms are becoming essential tools to process these huge data sets, looking for subtle patterns or weird anomalies that a human eye might just skim over.
And finding new things.
Definitely. It's already led to discoveries of things we hadn't noticed before. Maybe new kinds of stars, really faint, distant galaxies, lots of exoplanets orbiting other stars. It's like AI gives us a new way to see the universe hidden in the data.
That's fantastic. Unlocking secrets we didn't even know were there. Now, I remember reading about the Breakthrough Listen project. They're searching for alien signals, right? Does AI play a part there?
Oh, absolutely. Breakthrough Listen relies heavily on machine learning, sophisticated AI algorithms.
Why is that?
Well, they're scanning huge amounts of the sky, collecting vast quantities of radio signals. They need AI to sift through all that cosmic noise, looking for any faint pattern that might, just might, be artificial in origin, not natural static.
Trying to hear that one specific whisper in a galactic roar?
Exactly. It's an incredibly tough challenge, and AI provides the really powerful, nuanced tools you need to even attempt it.
Fingers crossed those AI algorithms find something amazing someday.
Okay, shifting gears a bit. What about planning the missions themselves, before anything even launches? Is AI involved that early?
Yes, increasingly so. It's becoming part of the mission planning and design toolkit. Engineers use AI-powered simulations now
Simulations for what?
to model and optimize pretty much everything about a mission. They can run thousands, millions of virtual scenarios, testing different trajectories for the spacecraft, predicting challenges it might face, figuring out the best way to use onboard power, timing maneuvers, all that stuff.
Trying everything out digitally first.
Right. We actually saw a great example with the Ingenuity helicopter on Mars.
The little drone.
Yeah. AI was crucial in modeling its flights and even helping adjust the flight paths in real time based on the actual Martian weather and the terrain it saw below it. Wow. So AI isn't just reacting during the mission, it's helping plan and predict before and during. Okay, we've talked robots, satellites. What about the humans? Astronauts on long flights, like to the space station or maybe future Mars missions? How does AI help keep them safe?
That's a huge focus, especially for longer missions where they're far from home. Astronaut safety and health are obviously top priority.
Absolutely.
So AI systems can constantly monitor the life support systems, air, water, temperature, pressure, making sure everything's stable. They can also help detect potential hazards, maybe a micrometeoroid warning or an equipment malfunction starting.
Like an early warning system.
Exactly. And it can even assist with medical situations. Imagine an astronaut having a health issue on Mars. Communication back to Earth takes time.
Right, you need help now.
AI could analyze their vital signs in real time, spot anomalies, maybe suggest diagnoses based on the symptoms, or even guide another crew member through a medical procedure using augmented reality or step-by-step instructions.
Like having an AI doctor and safety officer on board 24/7.
That's the idea. Providing constant vigilance and support for the crew's well-being, it must offer significant peace of mind on those really long, demanding journeys.
It really sounds like it. Now, this is really interesting. I also read that regular people like you and me can actually help train AI for Mars. Tell me about that project.
Yeah, that's the AI for Mars project. It's a fantastic example of citizen science.
Citizen science.
Yeah, basically NASA realized, hey, to train these AI algorithms really well, we need tons and tons of accurately labeled data. Pictures where someone has marked, this is rock, this is sand, this is a weird-looking feature.
Okay.
So they set up this website, AI for Mars, where anyone can go online, look at pictures from the Mars rovers, first Curiosity, now Perseverance 2, and help label what they see.
So I could log on and start identifying Martian geology from my couch.
Pretty much. In the beginning, with Curiosity images, people were mostly labeling basic stuff, like sand versus rock. That helped them build an algorithm called SPOC.
SPOC, like the Vulcan.
Yeah, stands for soil property and object classification.
Yeah.
And it got really good, like 98% accurate at telling sand from rock.
Wow.
Now, with the better cameras on Perseverance, the tasks are a bit more detailed.
Mm.
People are helping label things like float rocks, rocks just sitting loose on the surface, or nodules,
Nodules, what are those?
little rounded mineral clumps, often formed by water, so they're scientifically interesting.
Okay, so every time someone clicks and labels a nodule, they're teaching the AI. What's the big goal here?
Well, the main goal is to build AIs that can help the rovers be even more autonomous and efficient scientists. Vivian Sun, she's a JPL scientist working on Perseverance and AI for Mars.
Okay.
She explained that Perseverance sends back so many images every single day. The science team on Earth just doesn't have time to look closely at every single picture before they have to plan the rovers next day.
You're right. There's a time crunch.
Exactly. So imagine an AI on board the rover that could scan the images as they're taken and say, hey, science team, I think I see some really interesting rock veins over here, or potential nodules detected in this area.
It highlights the interesting stuff automatically.
Yeah, it would save the human scientists a massive amount of time, letting them focus their expertise on the most promising spots the AI flags.
So the AI acts like a super efficient assistant, pre-screening the data. It's not replacing the scientists.
Not at all. It's augmenting them, making them more effective. And what's really cool is what happens with all the labels the public generates.
What's that?
The AI for Mars team is making the whole labeled dataset public, free for anyone to use.
Open science.
Totally. Hiro Ono, the JPL AI researcher who led the AI for Mars development, he stressed this point. If someone outside NASA can take that public data and build an even better algorithm, great. That helps everyone and speeds up discovery.
That's a fantastic collaborative approach. So once these algorithms are trained up, using all the citizen science data, what could they do in the future?
Well, looking ahead, the idea is you could eventually upload these super-trained AIs directly onto future rovers or landers.
So the AI runs right there on Mars.
Exactly. Giving the rover the ability to maybe select its own science targets sometimes. Or filter the images it collects, only sending back the ones with the most scientifically juicy features.
Cutting down on the data transmission bottleneck.
Right. It would be a huge step towards truly autonomous science on other planets. Robots making discoveries with much less direct hand-holding from Earth.
The possibilities really seem huge. Okay, we've covered a lot about what AI is doing now. Let's think bigger picture. What's the long-term vision? What's the really game-changing potential down the road?
Oh, the long-term stuff gets pretty mind-bending.
Yeah.
Think about things like self-replicating robots.
Robots that can build copies of themselves.
Yeah. Robots that could land on Mars or the Moon, use local resources, and autonomously build habitats, infrastructure, maybe entire research bases.
Wow, so paving the way for humans without having to ship every single nut and bolt from Earth?
Exactly. It could dramatically lower the cost and complexity of establishing a long-term presence off-world. And then there's interstellar travel.
Going to other stars, the ultimate challenge.
Right. The distances are just
Yeah.
insane. AI would almost certainly be essential for navigating across those vast empty stretches, maybe over generations, and for managing the super complex, totally closed-loop life support systems you'd need for trips lasting centuries.
You'd need AI to keep everything running perfectly for that long.
Absolutely. And as we go further out, AI could also be key for, like, smarter, faster deep space communication, maybe dealing with signal degradation or finding clever ways to compress data.
So self-building bases, navigating between stars. It really does sound like science fiction becoming engineering challenges.
It does. And fundamentally, AI could just expand our understanding of life itself, helping us analyze potential biosignatures, maybe recognizing signs of life that are totally different from what we expect.
Broadening the search?
Yeah. Plus, there's the inspirational factor. Seeing AI push these boundaries could inspire whole new generations to get into science, tech, engineering, math, STEM fields.
And the tech developed for space often finds its way back to Earth.
Definitely. That's a classic pattern. AI developed for rover autonomy could improve self-driving cars here. Material science breakthroughs for spacecraft could lead to better products on Earth. Robotics, energy, the benefits often trickle down.
So pushing the limits out there helps us back here. A powerful cycle. But it can't all be smooth sailing. There must be big challenges, things we need to be careful about.
Oh, absolutely. There are major hurdles and serious things to consider. Reliability is, well, it's everything.
Job number one.
Right. AI systems in space have to be incredibly robust. A malfunction on a deep space probe isn't like your laptop crashing.
Yeah.
It could mean mission failure, potentially billions of dollars lost, or even risk to astronauts' lives. The consequences are huge.
You can't just send out a repair crew.
Exactly. So the testing, the redundancy, the error checking,
Right.
it has to be extreme. Then there's the data problem.
Not enough data.
Well, training good AI needs lots of relevant data, and getting enough data that truly represents the weird, harsh, specific conditions of space, deep space radiation, Martian dust, vacuum, extreme temperatures, that's tough.
You can't perfectly simulate everything in a lab on Earth.
Not perfectly, no. And you have to worry about the hardware itself. Space is harsh. Radiation can mess with electronics, so the AI systems need to be radiation hardened and designed to cope with potential bit flips or errors caused by cosmic rays.
Critical points. Reliability is non-negotiable, and getting the right training data is hard. Any other major considerations?
Well, there are also, ethical questions that start to arise as AI becomes more autonomous, especially if AI starts making really critical decisions far from human oversight. That's a whole other conversation, but it's definitely something designers need to think about carefully.
Right. The more independent they become. Okay. Well, this has been absolutely fascinating. A really deep dive into how AI is changing space exploration.
It really is touching almost every aspect.
Yeah, from letting spacecraft drive themselves across Mars to analyzing rocks, crunching telescope data, even getting the public involved in training. It's clear AI is completely revolutionizing how we explore the cosmos.
And it's not just solving today's problems, right? It's genuinely expanding what we even think is possible out there, changing the horizon.
It really does make you wonder about what's next. I mean, think about these increasingly autonomous AI systems going further and further out. What completely unexpected things might they discover, things we haven't even imagined yet?
Yeah.
And what does it mean for us, for our understanding of our place in the universe, if machines start becoming our main explorers in the really deep, distant parts of space? Lots to chew on there.
Definitely food for thought.
Well, thanks for joining me for this deep dive.
My pleasure.